Welcome back everyone to Learning with Teaching. We're in statics and today we're going to do problems 10.5 and 10.6, okay? So it says, determine the moment of inertia for the shaded area about the x-axis for 10.5. And for 10.6, determine the moment of inertia for the shaded area about the y-axis, okay? So now, let's just start by knowing the definition of a moment of inertia. So we realize that the moment of inertia with respect to, in this case, my x-axis, is going to be from all my area of y squared times the differential area, okay? Now, in order to use this definition, what we have to realize is that for this definition to be true, we need to know that all my points with respect to my x-axis, so I have my x-axis, and then our differential area, let's say, is like this. So we need to know that all the points are at the same distance x, okay? So I always think of my differential area has to be parallel with respect to the axis that I'm working on. So in this case, if I'm working for the x-axis, therefore I want my area to be horizontal, exactly like my x-axis. So our differential area will look something like this. Now, if our differential area looks something like that, then we will have that the height will be dy, and our base will be 1 minus this small section in here. Well, that small section in here is equal to x. So basically, we will have that this is equal to 1 minus x. Okay? So, now that we know that, we will know that my differential area, well, the area of that rectangle should be 1 minus x multiplied by dy. So now we can plug this into our moment of inertia. So we got the moment of inertia for all the area of y squared multiplied by 1 minus x multiplied by dy. We can check that we're going to do an integral with respect to the change in the y direction. So the y starts at 0 and it ends up in here, which is equal to, so if it's equal to 1 meters, okay? So we're going to start from, we can say that from 0 to 1. The last thing that we need to change is just we need to change this x. We want everything in terms of y, okay? So how can we do that? Well, we have the equation over here that is given to us, and we know that that equation is y equals to x raised to the 1/2, right? So we can solve for x, and we realize that x then will be equal to y squared. And we can use this and plug it back as my x. So if we do that, we have that our moment of inertia with respect to the x-axis from 0 to 1 will be y squared multiplied by 1 minus y squared dy, okay? Now, after having this integral, everything on terms of y, and with our boundary set up, our boundary numbers 0 and 1, what we can do is we're going to use our calculator. We're going to use math 9, and we will realize that this is equal to, so my second moment of inertia with respect to the x-axis is equal to 0.133 meters cubed. To the fourth, I'm sorry, not cube. And this should be the answer for my problem 10.5. So let's write that out, 10.5. For 10.6, we're going to do the similar process, just knowing that the basic definition for my moment of inertia with respect to the y-axis is going to be the integral of all the area of x squared multiplied by dA, okay? The difference between the moment of inertia with respect to the x-axis is that this one is going to be y squared and then this one is x squared. So knowing that and also applying that for the definition, what we need to know is that all the points with respect to my axis, this case the y-axis, have to be the same, the distance with respect to this differential area, meaning that from this axis, all the points on this differential area has to be the same. So saying that, what we need to do is that we need to find our differential area to be vertical. Okay? So now that we have our vertical area like this, well, we'll realize that this will be the x as our base, and our height is just equal to y. Okay? So for this differential area, it's going to be equal to y times dx. Okay, so let's plug this in here. So we got that our moment of inertia with respect to the y-axis is going to be x squared multiplied by y dx. Now from here we can check that our differential is going to be in the with respect to the x. So we can put our boundaries to be from 0 all the way to 1 meters. So we put our boundaries from 0 to 1. And the last thing that we need to do is that we're going to change this y in order to have all our variables only in respect to x. So that's good because we know that y is equal to x to the 1/2. So we can just replace that. So let's write that out. So we got the integral from 0 to 1 of x squared times x to the 1/2 dx. If you guys want, you can make this into one single x to the 5/2, but it should give you the same answer. And if we plug this into our calculator, we will realize that that integral is going to be equal to 0.286 meters to the 4th power. And this is our moment of inertia with respect to the y-axis, which is the answer for our problem 10.6. Okay? If you guys like the video, please push the like button, subscribe, and I'll see you guys in the next one.